so you can connect to your notes. For what it's worth, I am going to choose slightly different problems for the 430, by the way. And the 430, I promise I really will try to remember to record. If you wish for additional exercises to see, watch the video for the 430. Sure. Okay, anyway, but solving kinematic equation problems. Let me give you some problems. I've got so many problems. Take out your note sheet, your equation sheet, not your notes, but your equation sheet, and I want you to answer these questions as if it is the test. There is an issue here with studying. What I see from time to time, quite commonly, is people study, do practice exams using Google, ChatGPT, their notes, each other. I want to emphasize that if you do a practice test using the internet, and then you don't have an open internet test for the test, you're going to get a false sense of security. You're going to think you know more than you do. You're not going to find out what you need help on. If you wish to find out how you're going to do, practice as if it's the event. Practice as if it's a performance, and then you will perform like you practiced. So don't use the internet when trying a problem for the first time. I'm not saying the internet is useless. Once you do the practice test and figure out, oh, I could do this, this, and this, but I can't do this. Well, sometimes working backwards from a solution can help. But if you use a tool that you don't have access to on the test while doing a practice, you're gonna get a bad idea of what you know and don't know. That said, okay, so here is a problem. My car is moving at 10 meters per second. I stomp on the gas pedal for 5 seconds. And my final velocity is 30 meters per second. So again, I start at a velocity of 10 meters per second. I end at 30 meters per second. What is my acceleration? What is my average acceleration in this time interval? Question M. 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 Again, the question is, what is the acceleration, not the time, the acceleration. A car is traveling at 10 meters per second. The driver steps on the gas, and 5 seconds later, the car is moving at 30 meters per second. Find A. Again, don't tell me about S. Tell me about m per s squared. If you put in seconds, that is not acceleration, peeps. One more time. If I start at 10 meters per second and end at 30 meters per second, and it takes me 5 seconds, find A. Find the acceleration giving initial velocity, final velocity, and time. My dudes, you're not making me confident about 20% of the class hasn't answered. 5 seconds. Sure. There are 20 questions. There are 75 minutes, 4 minutes per question. 3 minutes per question, and give yourself a little time to check your answers. Okay, the correct answer is 4 meters per second squared. I use the definition. A is the change in velocity per time. My final velocity minus my initial velocity divided by the time interval. 30 minus 10, last I checked, is 20. 20 divided by 5 is 4 meters per second squared. Follow-up question, how far does the car go in those 5 seconds? Google question N, what is the displacement? There is enough information, by the way. If you know the initial and final velocity, you now know the acceleration, you know the time, you can absolutely, positively find the distance, the displacement. Use the equations that you've got, that you should have in front of you right now on your equation sheet. The units for distance, what are they? Meters, not meters per second. Meters per second is a velocity or a speed, not a distance. Look at your equations. You have got plenty of information. Plug in the values that you've got. You need to have these equations down. I will remind you, some equations that we have talked about I also encourage you to sanity check your answers, which is to say this is a really slow acceleration for a car, but your answer should be something sort of like how long an on-ramp is. 30 meters per second is 65 miles an hour. That's reasonable freeway speeds. 10 meters per second is an initial speed. If your answer is 10,000 meters, 10 kilometers, that doesn't really match up with the size of an on-ramp. 6 meters, 18 feet really is a little bit short for an on-ramp. So check yourself before you wreck yourself. and you will get many more answers correct. Okay, we're at half the class now. I would like rather more than this. Let me show you how to plug in. Here's how you plug in. Look at what you got. Look at what you want. Plug in. Solve solva. For instance, on the left-hand side, I've got, what is this? Displacement. That's what I'm looking for. On the right-hand side, I've got average velocity and time. I have both of these. What is the average velocity if I start at 30 and end at 10? What's the average of 30 and 10? Google form, average two numbers. Question O, average 30 and 10. I want you to show me that you could take the average of two numbers, average 30 and 10. This, chop chop, quick like a bunny. Oh, yeah, oh. Okay, good. Hey, let me just check. Average 50 and 60. What is the average of 50 and 60? If I speed up from 50 meters per second to 60 meters per second, what is my average velocity? That's P, yeah. I'm just checking to make sure you got the formula. You know how to average. Again, take the average of 50 and 60. Okay, I'm going to encourage you to reflect on this. The defining idea behind average is the number halfway between, in the middle of. Most of you've got 55 is halfway between 50 and 60. Good. If you missed that or were not able to answer in time, think about what the meaning of an average is. The formula for averaging is add them together and divide by the number. Okay, so 50 plus 60 divided by 2. Now, so the average of 10 and 30 is 20 meters per second. What is the time that it takes? Bazinga, 100 meters. But that's only half of you. Let's get it to the rest of the half. Maybe you used a different equation. V initial t plus half at squared. What's VI? I just said it. What's VI mean? What is the initial in this case? What's t? What does it mean? What is the time interval? What is a? And what is the acceleration in this case? What is t again? Oh, time. Okay. I want you to evaluate this expression. Remember PEMDAS. Do it on your own for 2 shakes of a lamb's tail. PEMDAS this sucker. Google Form Q, tell me what this evaluates to. Let's just check. Do a sanity check here. I have plugged in numbers. What happens when I evaluate? Use this formula, by the way, what I'm putting up on the screen. I want you to plug into that. Be careful, my friends. Okay, I've got 2/3 of you, but I'm still missing a third. Let's practice PEMDAS. Are there any parentheses? Are there any exponents? Yes, what is the exponent? How do I evaluate 5 with a 2 on top? That's a square. I multiply it by itself. Okay. What do I do for multiplication? 10 times 5? Last I checked, 50. 1/2 times 4 times 25? Addition and subtraction. 50 plus 50 is, last I checked, 100 meters. A third of you were still working on that or given a wrong answer. Please, for the love of God, drill and kill this on the interwebs. If this is a struggle, you need to drill this. You need to be at the Algebra 2 level. This is well below that, okay? If you're struggling here, please do not stop until you recover this mathematics. Okay, so what is the difference between doing it this way and doing it this way? Nothing. 100 meters is 100 meters. Let's show we could do it the last way. Plug it into that. What's VF? What's VI? What's A? What's X? 30 equals plus 2 times. I can count, yeah. And now no, X is 100. Do I get agreement here? Kerchow. Hmm? Okie dokie. Ready for another? Question me first. I will not give you anything that requires use of the quadratic formula. If I'm asking for time, you can always get it another way. For instance, V average t. If you've got displacement and velocity information, you could use, but you don't have to use. If you use displacement as V average t, you're done. Okay, one more variation with this. One more variation with this. My initial velocity is 30 meters per second. I turn around and go same time interval at 30 meters per second in the opposite direction. What's my average velocity? What's my average velocity? Initial velocity, 30 meters per second. Average, final velocity, negative 30 meters per second. Question R is, what's my average velocity? Initial velocity was 30. Final velocity was negative 30. What is the average of 30 and negative 30? Yeah, this is R. Chop chop. Some of you hit submit twice or make new response. That gives me muchly hope. I see a whole bunch of people not answering. Makes me nervous. You all clicked edit or submit new response. Let me please remind you, it screws with my head. It screws with the way that I run the class. If you hit submit new response on your Google form, don't do that. edit response every single time. Please, please. Don't, okay? Correct answer is 0 meters per second. Average velocity is 0 meters per second. The average of 30 and negative 30 is 0. Follow-up question. It takes me 5 seconds to go from 30 meters per second to turn around and go at negative 30 meters per second. What is my total displacement? What is my displacement? Google form S, what is my displacement? You can use any method you want. My initial velocity, 30 meters per second. I accelerate smoothly and go negative 30 meters per second at the end of 5 seconds. What's my displacement in that time interval? And this is, I'm glad I asked, because half of these are wrong. Again, 5 seconds time interval. I start at 30 meters per second. I end at negative 30 meters per second. I accelerate uniformly. What is my displacement? You can use the equations if you wish. You can also look at the question I just asked for a bigly hint. I am asking for displacement. Several people are telling me meters per second. Lots of people are telling me meters per second. I'm asking for displacement. We meant that in meters. Meter? I hardly knew her. Womp womp womp. Yep, this is important to go through. Again, I start at 30 meters per second. I end at negative 30 meters per second with uniform acceleration. What's my average velocity? Y'all just told me 0. Displacement equals average velocity times time. 0 times 5 is not 12. My displacement is 0 meters. Is that weird? But I've moved. How can I have moved and have 0 displacement? What does it mean to have 0 displacement? Where you end is where you started. Perfect. It doesn't mean that you were stationary the whole time. It means your final x minus your initial x is 0. Your change in x is 0. Your position is the same at the end as at the beginning. Okay, please reflect on that. You can, a whole bunch of people then said 0. A bunch of people who were saying 60 then changed to 0. You don't have to change your answers, by the way, because of what I say. Okay, anyway. I'm going to give one final nugget of wisdom. Free fall. When do you use A as positive G and when do you use A as negative G? Google Form, show me what you think. Here is the question. When in solving problems, this is Google Form T, when in solving problems do you plug in acceleration is positive 9.8 meters per second squared? When in solving problems do you plug in A is negative 9.8 meters per second squared? Again, under what circumstances do you use positive acceleration versus negative acceleration in free fall? If I have a Equation problem. What am I going to plug in? When am I going to plug in what for acceleration? Don't leave yet. Well put, Sadowski. I like that. One last time, the question for T is, when would we use A as negative G and when would we use A as positive G in solving a problem with free fall? Okay, think about this. Reflect on this, my grasshoppers, and achieve physics enlightenment. When you're moving up, what's your velocity? Positive. Are you sure? I'm positive. Moving upward is positive. What happens if you have a positive acceleration and a positive velocity? Do you speed up as you go up in free fall? You get faster and faster going upward into outer space, faster and faster the higher you get? I think you slow down as you rise and speed up as you fall. So your positive numbers, positive velocities get less positive velocities get less positive, and then negative numbers get more negative. How am I changing those positive numbers? Are they going up or are they going down? Positive numbers getting less positive. Is that an increase or a decrease? Increase or decrease? Shout it out. Decrease. Negative numbers getting more negative. Am I going up the number line or down the number line? Increase or decrease? Decrease. If I go from -1 meter per second to -10 meters per second, my velocity has decreased. Acceleration is always negative in free fall. Tricked half of you. Don't get tricked. It's very simple. Acceleration is always negative g. Velocity might be positive or negative, depending on going up, coming down. Acceleration, always negative g in free fall. When you're not touching something, when only force is weight, there. Okay, in the 430 class, I'm going to start out emphasizing a couple of force problems. I encourage you, if you need that practice, then watch the first part of that video. I love each and every one of you. Maroon half sheet, you can have an equation sheet. See you Wednesday.